skip that, skip that. Okay, here's really the crux of it all. Sorry?
Just kidding.
Okay, I'll go back. I just don't want to bore anybody talking about stuff that they know. All right, I'll go back. There we go. All right. So on the left here, we're talking about sheet metal. When you want to bend a piece of sheet metal, the minimum feature that you can ever achieve for a bend is the thickness of the sheet. That's the minimum radius you can achieve. It's a very well understood rule, and that's the minimum you can ever achieve. With 3D printing, you could make a very thick wall with a perfectly sharp corner, but because you never had to bend the sheet metal, you just printed it there. So you can kind of eliminate some of these constraints that conventional manufacturing has. With CNC turning, the minimum radius or the minimum feature that you can achieve is the radius of the tool that you're using to cut. And that's the exact same thing for milling, which is what's on the next slide here. With a milled object, let's say I have a solid block of aluminum and I want to create a pocket inside of it, there's two ways to achieve a square corner. You either have to, well, you can either get a non-square corner and just round it out and be stuck with the radius of the tool as the corner and not actually have a true square. Or the other way is to go past the corner and create space for the thing to fit inside of it. But you can never create a perfect corner using a radius tool because it has a radius. You're using a round tool to create a square hole. It just doesn't work physically. On the other hand, you can take a round tool and on the outside of an object get a perfectly square corner, but that's because you're passing past the curvature of the object. If you're doing a pocket, you can't do that physically. All right.